Hello, and welcome to 5-Minute Math. Today we are looking at the 7th grade concept of constant rates of change. This is standard 7.4a in the great state of Texas, and we are using item number 16 off the 2024 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. All right, so we've got a city that's using an average cost of $12 per kilowatt hour. We need to find a graph that best represents that relationship. All right, so when we see this word per, that gives us a clue that we're dealing with a rate. And so what are our two units? So we've got dollars per kilowatt hour, right? So that means we can represent it as a ratio with the first term in the numerator and the second term in the denominator. Dollars per kilowatt hour. So specifically, it's 12 cents, so 12 hundredths of a dollar, over how many kilowatt hours? Well, it doesn't tell us, so we can say per 1 kilowatt hour. If they don't tell you a unit, you can just say it's going to be 1 kilowatt hour. So we need to find a graph that best represents this. Well, as you can see, all the graphs start at the origin 0, 0. So it is proportional here, and if we want to, right, we can see that in our reference materials we have the constant of proportionality up there at the top, k equals y over x, and that's what that is. Okay, so that's what that k equals y over x, and so really what we're looking at is we're looking at our 12 cents per 1 kilowatt hour. And since the denominator is 1, right, you can still kind of just put it all together as 12 cents per, like that, kh. You don't really need that 1. So how do we find the graph that best represents this? Well, let's make a table of values. All right, so I'm going to say kilowatt hour here, and then because that's my x, and then my cost is going to be here. That's my y. Let's just put some values down there. So 1 kilowatt hour is 12 cents. So it could be A, could be B. Definitely not going to be C. Look at C is, I'm going to put the letters over here. C already has it almost 1 to 1. Actually, it's above 1 to 1, so that's going to be too big. Wow. Okay, D is just off the charts. That's not going to work either. That's got $12 per kilowatt hour is what that is. This is $12 per kilowatt hour. So it's at that 12 up there. It's 12 cents. Okay, so we've got two that we can look at here, A and B. So let's just put some more values, and I'm just going to count by 12s, right? 3, 4, 5, 6, 7, 8, 9. So let's see, 24 cents. And then we've got 36 cents, 48 cents. I want to see what I can do to get close to $1, because that might, since we don't really have the cents in the y-axis, it's just by dollars. I want to see which one gets as closest to $1, because that might be my deciding factor. 72, it's 84. 8 is going to get us 96, and then that is going to get us above that, right? That's going to get us that $1.08. So right between 8 and 9 is where it gets to be about $1, which means the dollar's right there. So let's see where that lands on each. This right here, it looks like it's right there, maybe 8.75. Okay, so that kind of works. It's between 8 and 9. And then the $1, yeah, it doesn't, oh, it goes to 12. Yeah, so that's not going to work. This x value is like 12 to 1. I'm really looking for that, like this 8.75 gets me to 1, because that's going to be right there between the 96 cents and the $1.08. So my answer is A.